and welcome. Matrix multiplication. Many students have problems understanding matrix multiplication, how to multiply two matrices. In this short video, I will show you how easy it is to do. First, let's remember, this is a 3 by 4 matrix, 3 rows, 4 columns. This one here is a 2 by 4 matrix, 2 rows, 4 columns. This one here is a 3 by 2 matrix, 3 rows, 2 columns. This one here is a 3 by 3 matrix, and it's called square matrix. Now, I have A is a 3 by 4. I have B is a 4 by 5. So A is 3 by 4, B is 4 by 5. These two numbers are the same. Then I can do the product of the two matrices. If these two numbers are not the same, you cannot multiply the matrices. Now, these two numbers are the same. The result will be 3 by 5, 3 by 5, 3 by 5. So now we need I need to show you how to fill up these blanks. So first, this one here, it's coming from the first row, first column. So 1 times 1 plus 0 times -3 plus -5 times 5 plus 7 times 0. You get -24. Now the second, still first row, second column is coming first row, second column, 0, 1 times 0, 0 times 1, -5 times 3, 7 times 4. You get 13. This one is first row, third column. You do the math, you get 26. You fill it up here. And now do the same thing now. First row, fourth column. You get 86. Now this one is now first row, fifth column. 1 times 5, 0 times 0, -5 times 1, 7 times -1, you get -7. Now we're done, we fill it up here. So we're done with the first row. Second row, green, is coming from the second row here. First column, the same thing, you get 14. Second row, second column, this one here, you get 45. Second row, third column, you get 35. And then you get 19. And then here you get -19. So we're done with the second row. Third row now, we have to fill up this here. So that's first row, first column, 5 times 1, 3 times -3, -2 times 5, -6 times 0, and you add them up. You get -14. Now, the second one here is the same, 5 times 0, 3 times 1, -2 times 3, -6 times 4, times 4, you get -27. Keep going. Third row, third column, third row, third column, another -27. Now this one here is third row, fourth column, you get 29. And then third row, fifth column, you get another 29 here. So I'm going to go back again and run it quickly here to show you how this are calculated. So we're starting from here. You just watch this here is now, it's going to stay until I'm done with all these columns, see? Now second, here you go, first column, second, third, fourth, fifth. 1, 2, 3, 4. And you get the answer. This is the answer. So A times B is this matrix. Now, the product is not commutative. It's not commutative. Matrix product is not commutative. So you can have 3 different possibilities. If A is 2 by 3 and B is 3 by 4, obviously since this 3 is the same as this 3, so you can do AB. But you cannot do BA. BA is undefined. This is a case where both AB and BA are defined, but they have different dimensions. If A is 2 by 3, B is 3 by 2, then AB is 2 by 2, and BA is 3 by 3. BA is 3 by 3, and they are not the same. They are not the same. Here is AB and BA are defined, same dimensions, but they are not equal. Very easy. You can find this is A, this is B. You times A times B, you find this matrix. B times A, you find this matrix, and they are not equal. Now, here is a different story. Matrix product is associative. So if AB and BC are defined, then ABC and ABC are both defined. AB times C or A times BC are both defined, and they are equal. And this is an important property because sometimes doing it one way is cheaper than doing it the other way. Here is an algorithm for matrix multiplication. Input two matrices. A is m by k, B is k by n, and the output is the product of the two matrices is m by n matrix. And you see we have three loops, and then at the end you will find the output C. And you notice here that every time I have a multiplication here, I have an addition as well. And the number of multiplications is m times n times k, and also the number of additions are m times n times k. So now, what's the cost of matrix multiplication? If m is n, if A is m by k, B is k by n, CAB is m by n. So the total number of additions is mkn, number of multiplications is mkn, total number of operations 2mkn, total number of operations is 2n cubed when m is equal to k is equal to n, and that we say that the matrix multiplication is of order n cubed. Here's a very simple example. If A is 30 by 90, B is 90 by 40, C is 40 by 20. Now let's see the cost just in number of multiplications to do AB first and then times C. Now when you do AB, obviously when you do AB, the result is 30 by 40, 30 by 40. So now cost of AB is 30 by 40 by 30 by 90 by 40. You get 108,000 multiplications. And then the cost of ABC, so you have AB now here, this matrix, you times it by C, you get 30 by 40 by 20, 24,000 operations, total 132,000 operations. If you do it now this way, you multiply BC first, and then you multiply by A. BC is 90 by 20. So cost of BC is 90 by 40 by 20, 72,000. Cost of ABC, now you have BC is done, BC is done. You are multiplying it by A now. So 30 by 90 by 20 is 54,000 operations. Total here is 126,000. So this is cheaper than this. So ABC is more cost effective in this example. And that's the end of matrix multiplication. Thank you and see you soon.